Hi there, in this video we're going to have a look at three-dimensional Pythagoras and three-dimensional trigonometry. So here we have a cuboid, and our first question is to calculate the angle between this line FC and the angle it makes, with the plane ABGF. Okay, so here is the line FC, and at this point here is where it meets this plane. So what we have to do is try and create a right-angled triangle. Now, two things to think about is when we hit the plane, you're going to think about going diagonally across it, like so that we end up directly underneath where we started from. And there is our right-angled triangle. So I'm just going to redraw that, so FBC, FBC. So this is the question, this is the angle we're looking for, and this is the only information we have. So that's not enough information to find out this angle. So we need to find either BC or FB. So it's time to look again at the picture, and this one looks good. So if we look at this triangle here, and I just draw it again, we've got 6 centimeters, 8 centimeters, and we need to find this. This is of course a right angle because it's a cuboid, and you should be able to use Pythagoras to find that this is 10. So FB is 10, so what I can do is put FB down there. Now, we have a right angle triangle, 2 sides, 1 angle, SOHCAHTOA. Just have to work out which ratio, and because this is the hypotenuse and the adjacent, you can use the cosine ratio, and you should know that the cosine of any angle is equal to the adjacent side divided by the hypotenuse. Pop the numbers in, and to get the angle on its own, we're going to use the inverse of cosine, which is cos to the minus 1. You might have to press the shift button on your calculator, and you get 51.3. Let's have a look at another example. So we're going out the cuboids into some sort of pyramid shape, pyramid prism, triangular prism. So here we have the angle between TB and the base ABCD. Okay, so this flat surface here, this plane or this base, whatever they want to call it. So the line TB is hitting the plane here. And like I said before, you want to go diagonally across, but we're not going to come all the way across to here because you have to come across so you end up directly underneath where you started from. So we're actually going to come across to M, and then we have our right angle triangle. So as soon as we hit the plane, go diagonally across it so you end up underneath where you started from. I'm going to draw this, so TMB, and this is the angle here where this line meets with the plane. And again, not enough information. So let's have a look for another triangle. So this one here looks good. We know this is 7, so this length here is going to be 3.5. Again, Pythagoras' theorem, we're going to square them and add them. Don't forget the square root. And I'm going to leave it like this because it's a nice exact number. If I start rounding, I'm going to lose accuracy. So let's put that down there. MB, this is MB. This time we have a different ratio. We have the opposite and the adjacent. So this is the tangent ratio. So tan of any angle is equal to the opposite over adjacent. Pop the numbers in. I just use my answer button here because I already had this on my calculator. Inverse tan, and we get 29.5. We're going to have a look at one more example. A square-based pyramid. And we're told the apex, this is this highest point here, is directly above the center. So what that means is when we drop this line down, we're going to hit right in the middle of this square. And that's the question. Calculate this height, this perpendicular height of the pyramid. So the fact that it's saying perpendicular, it's got to be a right angle. We've just got to think of a good way of doing this. Now, we're hitting this plane, so it's worth going diagonally across it. So I'm going to look at either that one, or you could have gone this way, you could have come this way. It's completely up to you, but I've chose to do it that way. And I'm going to call this point here P, I think. So let's draw this triangle out again. So we've got E down to P across to C. The slanted length here is 12, and that's the question, what's the perpendicular height? Okay, well we can't do it because we need this side. So can we find PC? Can we find this length? So let's look at this big triangle here. And yes, it is a square-based pyramid, so it looks like we don't know this, but we do because it's 10 by 10. So if we draw that one out, 10 by 10, Pythagoras, 10 squared plus 10 squared, 200, square root of 200. Your calculator, if you haven't done surds yet, will tell you it is this answer here. So 10 root 2 is A to C, this big length here, but remember we only want P to C. So half of 10 is 5. Again, no trigonometry involved in this, so this is just Pythagoras twice. So 12 squared, take away the square of 5 root 2. Don't forget to square root it. So it's 12 squared, take away this squared is 94. Square root of that, just leave it as square root of 94. That's what they mean here in this third form. You could hit your SD button and have decimals. It's really not necessary. Just leave it like that as an exact form. Okay, I hope that video clears a few things up for you. You're happy with 3D trig, 3D Pythagoras, and now it's just time to go away and practice. Best of luck.